Okay, this is a lesson 9.4 from our Algebra 2 textbook. This is Mr. Dittmer, American Indian Public High School. The objective is to multiply and divide rational expressions and use them to model real-life quantities. Um, and I'm going to be tabbing back and forth mostly on these two tabs, this one and this one here. I've got a few problems set out. So I'm going to be mostly on this Educations tab, but I will occasionally go back to this Web Whiteboard tab. Um, so again, there's your objective. And so we're going to get straight to it and start multiplying and dividing rational expressions. But we're going to start with something a little bit simple, which is getting them into simplified form, because that is really what tricks people the most about this. Simplified form means that you factor out any common factors. So for example, if I have AC over BC, then I factor out the C's and I get A over B. So first example, I have x squared plus 5x over x squared. So the common factor, first I have to factor these things. So that looks like on top, if I factor what's on top here, well, both of these things have what they have in common is an x, so I'm going to pull that out front. It's the greatest common factor, and it leaves me with x times x plus 5. And x squared is x times x. I'm not going to write it out that way. I'm just going to write it as x squared still. And if I have an x on the top and an x on the bottom, that's what I'm going to factor out. So this equals, simplified form, x plus 5 over x. So that's getting it to simplified form. And that's as simple as I can get it. Now, what a lot of people want to do, so don't do this. They want to do this. And you can't do that because you can factor out, you can take out common factors, can't divide out common factors. You can do that. You can divide out common factors, divide, but you can't divide out common terms. See, x and x here are common terms. In subtraction, we subtract like terms and we add like terms, but this is division. We can't divide like terms. We can divide common factors, and this is not a common factor. And so yeah, so my final answer would be x plus 5 over x. That's simplified form. All right, it gets a little trickier with polynomials, but we just got to remember how to factor this thing. So so I'm going to factor the top first. What multiplies to 12 to negative 12 and adds to negative 4? So and why am I asking that? Because this is one of these problems. And so the two numbers on the right side are going to multiply to negative 12, and they're going to add to negative 4. And then when I FOIL it, I'll get that trinomial up top. So there it is. I've got 6 and 2 multiply to 12 and subtract to 4. I want it to be negative 4, so I'm going to have the 6 be negative and the 2 be positive. And then on the bottom, I have a difference of squares. Well, that's x plus 2 times x minus 2. And then it just becomes a matter of, now we've got common factors. So this works the same way now as it did on the previous page when it was just x that was a common factor. Because it's multiplication that's happening on top, x plus 2 is a factor, both on top and on the bottom, so we get to cancel it out. And my final answer really, I'm just going to cancel these x plus 2's out, and then box this as my final answer, x minus 6 over x minus 2. And again, yeah, the x is there in both of them, but it's not a common factor. So I'm done right there. All right, next example. Now we've got monomials. Now, look, there's two ways to do this. You can multiply across and say 30 over 20 and then reduce, or to 3 over 2, or you could cancel first. In other words, divide first and then multiply. You could say, oh, well, 5 and 2, that's 1 and 2, and 6 and 2, well, that's 3 and 1. So either way you want to do it, it's okay. So since I've started doing it that way now, I'll do it that way. So so I know I'm going to have a 3 on top and a 2 on the bottom. And then I can basically look at the top, and x squared times x cubed is x to the 5th divided by x, so x to the 4th is going to be on top. Y times y squared is y cubed divided by y cubed is, oh, now all the y cubes, I'm out of y cubes on top, and divided by y one more time. So it's basically y cubed on top divided by y to the 4th on the bottom gives me a y on the bottom, and this is my answer. All right, next one. Getting more complicated, so I've got to factor, then multiply. So I'm going to factor the top left, start from the top left corner. 4x goes into both of those terms, so it's 4x times goes into 4x one time. That's an x, regular x. And it goes into 4x squared x times. And on the bottom, this is a trinomial that I bet I can factor. Multiplies to -3 and adds to +2, +3 and -1. Okay, and they're setting up a hard thing here, which I'll explain to you in a second. What I'm saying when they're setting up a hard thing has to do with the way this relates to this. But before we go there, x squared plus x minus 6. So again, I see a trinomial. What multiplies to -6 and adds to +1? That'd be +3 and -2. And then 4x is as is. And then you can start immediately doing some canceling, right? 4x and 4x. X plus 3 and x plus 3. Now, what I was saying about these two is that one is the opposite of the other. Whenever you have a subtraction problem reversed like that, so that's essentially -1. That whole circle thing I just circled is -1. And so really what we have as our final answer is negative x minus 2. The denominator is all canceled, so it's just over 1, you know. So I don't even need to write a denominator. This is my answer, or you could call it 2 minus x. Or negative x plus 2. All your way of putting it. All right, next one. Okay, this is, in a way, this is easy. All they're doing is saying, this is a times sign. So it's just like what we were doing on this side, except on this side, we don't have a fraction, we have a polynomial. But any polynomial can just be written as a fraction over 1. So now it's easy. But what is hard is that we have a cube thing in here. So let's pause and ask about cubing. Where do we learn how to solve factors that are cubed? And the answer is section 6.4. On page 345, you have a formula that tells you how to find the difference of two cubes, how to factor the difference of two cubes. And using that formula, you can go ahead and solve it out. It's so this is really 2x parentheses cubed. So in fact, oddly, the example they use on page 345 is this exact example. It's 2x minus 1. and then it's 4x squared plus 2x plus 1. And this all times, well, the exact same thing, as it turns out. And so these cancel, this and this. And you're left with, for your final answer, x plus 3 over 2x minus 1. Again, x and 2x are like terms, but that doesn't matter because we're dividing, not adding or subtracting. Therefore, we can't get any more close to a final answer than that. And I'm just double checking. Yeah, that is right. Okay, last one for this video. What happens if we divide fractions? Now, whether we're adding, subtracting, or dividing, we got to make sure we factor everything. Therefore, like, I can't factor 5x by itself, but 3x minus 12 I can factor, so I better do that. And then what I want to do is just change my division into multiplication. So change that to multiplication, and what was on the bottom is going to go to the top, and what was on the top is going to go to the bottom. So x squared minus 6x plus 8, so what multiplies to 8 and adds the negative 6? Negative 4 and negative 2. And then x squared minus 2x, well, what term do they both have in them? X. And then we're just going to cancel everything we can. Cancel this. Cancel this. And then we have 5x over x, so the x's cancel. And so I'm left with 5 over 3. Okay, that's the last example on educations. Now I want to jump to this website, this tab over here. And if we, whoops. Okay, this is a word problem. It's numbers 50 and 51 on pages 559, on page 559. And the problem says almost all of the heat energy generated by a long distance runner is released in the form of heat. The rate of heat generation, H sub G, and the rate of heat released, H sub R, are modeled by these two equations. So, where K1 and K2 are constants, and V is the runner's speed. So what's the ratio of heat generated to heat released? Well, that's easy enough to write that as a rational expression. We just need to write that the one fraction over the other fraction. Like the answer to this first question, it's actually number 50 in your book, to this question, is just this fraction here. You just, the two formulas they gave you, just write it as a fraction, and that's actually your answer for 50. Although, I suppose we should write it in simplest form, which means that, now these are two different constants, so I'm not going to mess around with k, but h cubed over h squared becomes just h on top. So I would simplify that if I had more time. The second question asks, when this ratio that we just wrote equals 1, how is height related to velocity? So let's just make it equal 1. That means K1H, the numerator equals the denominator. So K1HV equals K2, HV equals a constant, K2 over K1. And that means that there's an inverse relationship. So the taller you are, the slower you are going.